Swayam Prabha. Digital India. Educated India.
I can also write 2 NaCl as Na2Cl2 because this is just a formula unit. I can write any way I want. Now imagine each chloride I am replacing with the oxide. 1 chloride, 1 oxide. So 2 chloride, 2 oxide. 1 sodium I replace with lithium. Another sodium I replace with. So I got a new compound LiCoO2, lithium cobalt oxide. Now tell me what is the oxidation state of lithium here? This girl, green. This is +2. How much is the charge on the anion? Correct, no? So cobalt is in 3+ state, lithium is in 1+ state. Clear? Now it is electron neutral. So if I form this compound, this must be the oxidation state, otherwise I cannot form this compound. Am I right? So if I take the lattice of oxygen, lattice of oxide, like sodium chloride, we have lattice of chloride, no? Like that I make a lattice of oxide, and in the octahedral voids I throw lithium and cobalt. Then I get structure of lithium cobalt oxide. That's why I replaced the sodium with lithium and cobalt. Because sodium, it was in octahedral void. Therefore, lithium and cobalt also must be in octahedral void. But lithium and cobalt are very distinct in ionic radii. Therefore, they don't mix. One particular octahedral void will be taken by lithium, another particular octahedral void will be taken by cobalt. So it will go one after the other like a layer. You see here, 1, 2, 3. This 3 will be taken by lithium, and this taken by cobalt, and this taken by lithium. Correct, no? So you have a layer. In between the layer, you have oxide. The red ones are oxide. Now tell me one thing. The plane which contains lithium or cobalt, what is that plane called? Have you heard of some indices? Miller indices. Using Miller indices, can you tell me what is this plane where this 3 lithium is there? What is the plane in which all cobalt is there? How many of you know Miller indices? You know, other than that? Nobody know? What is in your textbook? First of all, I don't like concept of textbook. Why should we give textbook? There are reference book. Syllabus only we should give, you should go read whatever you want from the reference book. The concept of textbook is only killing the students. But everyone thinks only from there question will come. Then your knowledge will get limited, no? Textbook culture you have to destroy. Right, no? You do not give. I never give notes to my students. I only show the slides, then I will go away. I tell them, you go find your way of writing your own notes. Because if I give, you will limit it to this. You go find out. Here also same thing, I will not give. So whatever you write down is what the matter. Now tell me. What is the question I asked? What is that Miller index of that plane? How to find Miller index? You have forgotten. Now let us do this. Okay, let us say this is my x-axis, this is my y-axis, this is my z-axis. Okay. If I go 1 unit along the x-axis, okay, this is my x-axis, no? If I go 1 unit along the x-axis, I will be here, and then I will be parallel to y and z. Then which is that plane? This is that plane, right? I went 1 unit along the x-axis, parallel to y and z axis. Okay, so this will be parallel to that fellow. It will not be disturbed. Then that plane will be 1 0 0 plane. 1 0 0, right? If I am in the midway, suppose take midway. This plane will be right, half away. So inverse of that you have to take for Miller indices. So that is 2 0 0 plane. 2 0 0 plane means in the x direction halfway you go. That is 2. 1/3 if you go, it will become 3. 1/4 if you go, it will become 4. When I say 4 0 0 means 4 0 0 will come exactly between these two. Correct, no? So this is 2 0 0 plane. Similarly, if I go 1 unit along the x axis, 1 unit along the y axis, 1 unit along the z axis, 1 1 1 plane. That is this plane, na? See, I have gone halfway here, halfway here, halfway here. It's equivalent to saying 1 1 1. Half half half. Then inverse of that will be 2 2 2. So this is a 2 2 2 plane. 2 2 2 plane is equivalent to 1 1 1 plane because they are the same family. Where between 2 1 1 1 plane, 1 2 2 2 plane will come. For example, here this is 1 0 0 plane. This is also 1 0 0 plane. Between that you get 2 0 0 plane. Correct, no? Similarly, 1 1 1 1 1 1 in between 2 2 2. Correct, no? They are same family. 1 1 1 1 family. So this is in that direction. This is 1 1 1. This is 1 1 1 family. This is 1 1 1 family. Between the 1 1 1 family, you have again 1 1 1 family of oxide ions. Because between the two cations, one oxide ion has to come. Otherwise, the cations will repel each other. No. So you have lithium layer, oxide layer, cobalt layer, oxide layer, lithium layer, oxide layer, cobalt layer, goes on. Correct? That's how it looks. So now let us calculate the molecular formula like we did earlier. If we do that, I have 6 lithium here, 6 into 1 by 4. How much is it? 1.5. Now I have here 1, 2, 3, 4, 5, 6, 7 are there. This 1 is completely belong to that. Then you calculate, it will become 2.5. Correct, no? Because these are all edge center. 6 edge center into 1 by 4, 1.5. This one completely belong inside, so 2.5. So cobalt is 2.5. Oxide is 4 because this is the lattice, FCC lattice. So oxygen is 4. Now the formula is not LiCO2. Is it not LiCO2? Because this is 1.5. If you divide by 1.5, this will become a fraction. It will not become a whole number. So it is not. If it would have been a whole number, then it should become different, right? LiCO2 should come. If I make it O2, then I have to divide both by 2. Both if I divide by 2, then this will become 0.75, this will become 1.25. It is still not LiCO2. That means this is not unit cell of this system. Why this is not unit cell of this system? Because I derived from sodium chloride, then it should be. No. In sodium chloride, cations were indistinguishable. All were sodium. Here your cation is distinguishable, lithium and cobalt. What is a unit cell? It is a minimum volume which repeats itself in the space. That minimum volume should contain the same thing in everywhere. So that minimum volume, if you try to construct, it will come out to be a rhombus. It will not be cube. Why rhombus? Because this layer is different from this layer from this layer. So I need to connect it like a rhombus, it would come. Okay, like a rhombus, it will come. That rhombus only will make this unit cell. Now let us look at that rhombus looks like this. You see here. This is a unit cell. How you will look at it? Very simple. I told you oxide ion is forming FCC lattice. What is FCC lattice? A layer, B layer, C layer. Now let us take this is oxide. This is A layer. This is B layer. This is C layer. What's between the A layer and C layer? You see the triangle is facing in different direction. Correct? No? This is a triangular lattice. Agree? 1, 2, 3. You connect. This is a triangular lattice. So this is a triangular lattice. Here I have not shown the other part of the triangles. Only one triangle I have shown. So, but these positions are different. So therefore, this is a B layer. This is a A layer. Then this has to be C layer. After this, you will get again A layer, B layer, C layer. It will go like that, right? A, B, C, then again A layer, B layer, C layer. This A layer repeats here. You see this triangle and this triangle exactly same. Correct? Now between this oxide layer, I have to throw cobalt and lithium. Lithium is red one, cobalt is blue one. So cobalt layer also, if you see carefully, go back and see, it's a triangular lattice. You can connect any 3 lithium, you get triangle, right? It's a triangular lattice. So this is also triangular lattice. So it will be having this kind of shape. So I put cobalt between the A layer, below that it will be C layer, right? A layer, here C layer will be there. So between C and A I put cobalt. So between C and A I put cobalt. Correct? And between A and B I put lithium. Between A and B I put lithium. So I repeat it like that. How long I repeat? Until I get again cobalt between C and A. Am I right? Then only it is unit cell. Same point you have to reach. But it's only in one direction I am showing. And B and C direction I am not talking about. Only one direction I am not talking about. Now let us do that anyway. Cobalt is at the interface of the unit cell, 2 unit cell. This cobalt also is at the interface of the 2 unit cell, correct? Now let us do the calculation. I have already given calculation here. You also do it. Let us do it for lithium first. This is a 3 lithium which is inside the unit cell. So we will give entirely to that. And this is the lithium. Where it is? This lithium connected to how many lithium? Each lithium connected to 3 more lithium, right? So within the layer it has a sharing of 1/3, correct? And this is inside, that's belong to that, so plus 1. And here again 3 which is inside, plus 3, so 9. Now let us do for cobalt. This cobalt is at the interface of 2 unit cell. That means within the layer each cobalt connected to another 3 cobalt. But because it is at the interface of 2 unit cell, it is divided half. Because this cobalt is common for this unit cell also, this unit cell. So 6 into 1/3 into 1/2. That 1/2 comes because it is at the interface of 2 unit cell. 1/3 comes because within the layer it is connected to 3 more cobalt. Plus 1 into half, which is the 1. This 1 into half, why it comes? This particular fellow here, it is a common. So 1 into half. Plus 3, this 3 is this 3. Plus 3 is this 3. 6 into, again 1 3 into 1 half is 1 6, no? Same thing which is done here. Plus 1 half, this 1 into half. It becomes 9. Do the same thing for oxide. What happens? Look at the oxide. 3, this one. 6 into 1/2. 1/2 won't come here. Why? Because it is not at the interface of 2 unit cell. Therefore 1/2 not there. Plus 1, this is the 1, oxide, no, oxide is this, 3, correct? Again 3, then 6 into 1/3, again 1, that 1 is in the middle, again 3, that 3 is here, 18, right? Now Li 9, CO 9, O 18. You divide by 9, you get. So now is the molecular formula, correct? But now be careful. This is an hexagon, right? Look from the top. It will look like this. Okay? It will look like this. Now what I have done? I have divided this hexagon into 3 parts. If you look at carefully, you can understand whatever is here is what here. Whatever here is what here. The content is same. Correct? Look at it. You can cut this. You start from here, cut it like this with 4 atoms here. Okay? Or you start from here, cut these 4, right? Or take from here, cut these 4. So it becomes 3 parts. But all the 3 parts, if you calculate this number of lithium, cobalt and oxygen present in those 3 parts, they will be equal. So according to definition of unit cell, we have to take the minimum volume which is required to repeat in the space. So this length is okay for us, but the A and B, we don't want as we have written here, we need only 1/3 of it. Why 1/3 of it? Because in 1/3 whatever is there, because there are 3 parts, no? This 1 full become to 3 part. So 1/3 if I take, the same information is there in the remaining 2/3. Therefore, I don't divide by 2, 9, I divide by 3. If I divide by 3, it becomes Li3, CO3, O. That means in one unit cell, 3 LiCO2 is there. In one unit cell, 3 LiCO2 is there. What is the shape of this? Rhombus, rhomboidal. That's why this unit cell is rhomboidal. It is not cube. Why it is not cube? Because there are 2 cations. So if you wanted to get the minimum volume that is required to repeat in the space, you cannot do it with the cube. Although your lattice is a cubic lattice. Your lattice is actually made of anion. That is still FCC. But unit cell is not FCC. There is a difference. Lattice is different from unit cell. Because your lattice is FCC, your unit cell you cannot expect it to be cubic. No. This is a classic example for that. Correct? No? Now, this is called LiCO2. Now, I have done graphite, I have done LiCO2. Now, you may be wondering why he is teaching all those things. How does it related to electrochemistry? Remember, we have done hydrogen electrode as a reference. How did we do? We added plus 4.5 electron volt and did. Now somebody comes and tells me, I don't want hydrogen electrode to be my reference. I want only lithium to be my reference. Then how much you will add? 1.3. Correct, no? So I can make my lithium as my reference. I can find out the potential of the other electrode. It's very much valid. It's only our option, right? Who has to be reference is our option. How will you measure the height of the building is my option. Should I measure from the basement? Should I measure from the core of the earth? Should I measure from the sea level? It's my option. But whatever the way you do, truth will remain truth. Can this change? Because you measure from somewhere else, will your building change? It won't. Same here. I am now going to use lithium as my reference. So lithium plus hereafter my reference. With respect to that, I want to measure the potential of some electrode. Now lithium cobalt oxide, I am going to remove some lithium. See, when I say lithium cobalt oxide, it is not molecule, it is an extended solid. There is a difference between the molecule and extended solid. Like let us take methane. Methane is a molecule. Why? Between one methane to another methane, what is the force? Imagine you are making methane solid. What will be the force between one methane to another methane? Electrostatica. What is that intermolecular force? There are many force name, no? Van der Waals force. Okay. Now lithium cobalt oxide you take. What is the force between lithium to oxygen? Electrostatic. Li plus O2 minus. Then the Li plus is interacting with many O2 minus simultaneously. Then we cannot define what is the molecule here. Because Li plus in this direction is having some electrostatic interaction with oxide. In this direction also it is having an electrostatic interaction. Now how will you define the molecule from here to here? You can't. So for this kind of compounds we can only define the formula unit. What is formula unit? LiCOO2. What is molecule here? No molecule, because it is an extended solid. In all directions it will look same. Whereas in case of methane, if you make a solid, one methane, within the methane C and H has a covalent bond. Between the methane it is van der Waals force. So you can distinguish. Whenever van der Waals force comes, I can draw a boundary and say this is molecule. Right? Methane is not having a carbon which is coordinating in all direction with hydrogen, the hydrogen coordinating again with the carbon. It is not like that, no? Correct, no? So if we take water, water is a molecule because between one water to other molecule of water, there is no covalent bond, there is hydrogen bonding. So wherever hydrogen bonding comes, I draw a line and say this is a molecule. But I cannot do it for this material, this is a extended solids. So now I have Avogadro numbers of this formula unit in a solid when I take. Avogadro numbers mean too many. Now I am going to charge this battery. How will I charge? I have to remove electron from one electrode, put it in the other electrode. If I take electron out, because when you take the electron out, excess positive charge will develop here. Then that positive charge also has to be pushed out. Correct? Now the positive charge coming out is lithium. I take X lithium out. When I take X lithium out, X is a fraction. X electron also will come out. Then only the structure will remain neutral. Since I lost X lithium, I will have Li 1 minus X COO2, correct? Yes or no? X lithium went out, X electron went out. Where the electron came from? Because lithium here, someone told me it is in the oxidation state of 1 plus, no? Now same 1 plus only outside also. Then electron would have not come from lithium, it has come from somewhere else. Who has given? Who has given that electron? Cobalt, because it is a transient metal. It can have a variable valency. Also it can have oxide also. Oxide, if it gives electron, become peroxide. So now you see cobalt. Now I am going to write very precisely Li 1 minus X cobalt X cobalt 1 minus X O2. Why did I do this? Why did I do this? Why? See, I got only X electron out. X is a fraction, that means less than 1. So if I take X electron out, that would have been given by only X cobalt. Then remaining 1 minus X cobalt will be cobalt 3 plus. This is 3 plus, na? Correct? So X cobalt has gone to 4 plus. Remaining 1 minus X cobalt still lies as 3 plus. Correct, no? Clear? Now this is one half of the reaction. What is the other half? Graphite. Remember this material we discussed. X is less than 1, right? Fraction. Now you see lithium left LiCO2, got into graphite. When you remove lithium from this structure, it has come from the octahedral voids. When you take out from a void, we call it as a deintercalation. What is that? This is getting into the void that is between the graphene layers. It's called intercalation. It is intercalated here, here it got deintercalated because it means it has come out from the specific void. That's all it means. Now add right, this is a reaction, correct, no? Make sense? Now, this material has got a reduction potential of roughly about 3.5 volt with respect to lithium plus reference. See, I changed my reference here, not SHE anymore. Lithium plus. With respect to that, it has got a positive value. So that means lithium plus will have 0 now. So this is 0, this is 3.5. Then which will be my cathode in the galvanic mode? You remember we combined lithium to hydrogen. Hydrogen was 0. Wait. We combined lithium to hydrogen. Hydrogen was 0. Lithium was minus 3.04. In the galvanic mode, which one was anode? One which has more negative potential, reduction potential was anode because there is more electropositive. Correct, no? Same logic you use here. Here lithium is 0, lithium cobalt oxide is 3.5. So which will be my anode in galvanic mode? One which has the least value is the anode. Minus 3.4 and 0, which was the anode? Minus 3.4. Now 0 and 3.5, which is more negative? 0, no? Then 0 must be your anode. Correct, no? 3.5 is positive value, no? That should be cathode. I am talking about galvanic mode. Galvanic mode means energy will be released. Chemical energy converted to electrical energy. Now, what is the galvanic mode here? Galvanic mode here, because this is 0 and this is 3.5, then this must be my anode, this must be my cathode. So, anode should give the electron out, no? Right or not? Oxidation should happen. Then that means this will oxidize, this will reduce. That means the direction will be, if this has to give electron, this should happen, no? Then only electron will come. Right? So, this is galvanic mode. This is electrolytic mode. Right, no? Yes or no? So, in galvanic mode, this will oxidize, it will act as an anode and this will reduce. That means de-intercalation here, intercalation here. But when you are charging, you go this way. Why I wrote first electrolytic mode instead of galvanic mode? Because you can't make this material in the lab. You can only make this material. So, electrochemically I can go from here to here. That is a soft route. What is soft route? I apply potential, pull the electron out. That is a soft route. But I can't make Li 1 minus x CO2 in the lab. So, I have to first make material in the discharged form. This is discharged form. Why? When this goes this way, then you get this in the discharge form because there is a galvanic direction. At the end, the product is a discharge product. So, I make it in the discharged form. Then, so I start the cell with the charging, which is electrolytic. Once you charge, the battery is ready for discharge. Make sense? Clear, everybody? So, now your solid state knowledge you have is used in the battery. Clear? Now, interesting. You see this animation. I am going to show the lithium in the octahedral voids. How it will go? Because when I say lithium is removed from here, that means in the lattice, lithium is moving, right? When you are taking a lithium out, lithium has to come from the lattice. That means when one lithium goes out, there is a void. The next lithium here will come there. Then that lithium will come here. Like that, like a train, it will move. So, until all the lithium from the particle taken out, it will happen. Correct, no? So, how that happens, you will see. Why? You see lithium inside the octahedra. It is coming to the triangular window. If lithium comes to the triangular window, where it will go? Remember, the triangular window was shared between octahedra and. So, if the lithium comes out of the triangular window, it will land in the tetrahedra. And from the tetrahedra, it will come out, it will go to again octahedra. Correct, no? So, like that, lithium is moving in the lattice. From one octahedra, it will go to another octahedra via a tetrahedra. If it has to go through a tetrahedra, the tetrahedra has to be vacant. Correct? Otherwise, when somebody is there, can you go in? Our people will go. When bus comes and stops in the bus stop, before that fellow gets on, these fellows will go in, right? You guys have some civic sense, You cannot do like that. You have to wait until people disembark. You don't follow those things. But the ions will follow. They will come out of the octahedral void, land into the tetrahedral void, then exit again through the triangular plane, get into the another octahedra void. Clear? I am going to replay this for you. See, the center one is a lithium coming out of the triangular face, land in the tetrahedra, come out of the triangular face, which is again shared with other octahedra. Like that, lithium moves from one side to another side, for which tetrahedra has to be empty. You remember, we derived LiCO2 structure from the sodium chloride structure. In sodium chloride structure, was tetrahedra occupied or empty? Empty. Because we put sodium only in the octahedral voids. We never bothered about tetrahedral voids. So, it is empty. Again, when I derive the LiCO2 structure from sodium chloride structure, I only replaced sodium with lithium and cobalt. Therefore, I am still utilizing only octahedral void, not tetrahedral void. Correct or not? So, they are empty, they are available for the lithium ion conduction. Correct? So, now what I will do? I will go back. I will stop here with the charge discharge curve. Okay. Now, you remember what is capacity? Capacity is nothing but charge, milliampere hour per gram. Now, when I charge the battery, what I am doing? I am taking electron from one side, putting into the other side. It is like filling water tank. So, with the time what is happening? Water tank is keep getting filled. So, I can plot how much water tank is filled with time. So, let us take this simple example. I have this water tank, this is sump, from there water is going there. With the time what will happen to the water level here? Increase. What is the potential energy? Potential energy is the height at which water is present. H rho g, correct? Height, density into gravity, H rho g is potential energy. So, now I want to plot potential energy versus capacity. Capacity. The full capacity of the tank, I assume it is 1000 liters. Okay. I am filling 100 liter per hour. How much I am filling? Now, let us do it. 1 hour over, how much water would have gone? 100 liter. Suppose if, okay, one more thing I will give you. This height is say 10 meter. Okay. What is potential energy? H rho g. Rho will not change, g will not change. Only H will change now. When I put the water, height inside that only will change. Now, I am putting at 100 liter per hour. How many hours it will take to completely fill? 10 hours. So, I divide into 10 portion. So, in 1 hour, how much height it would have gone? 1 meter. So, what is the potential energy? H is 1 now. Now, capacity, how much would have filled? What is the time here? Now, 2 hours, how much would have filled? What would have been the potential energy? So, my first point here, second point here. Then, rho g, correct? So, it will go like that, right? Am I right or not? So, you see I can plot potential energy versus capacity. Potential energy versus or potential energy versus time. Correct? Now, imagine I filled the tank. Now, I am discharging the tank. So, I am again withdrawing through the pipe 100 liter per hour. Correct? It will go like that, come back. Now, look at this curve also going like that, coming back like that. So, this step is charging the battery. This step is discharging the battery. How will you measure the capacity of the battery? In water tank, we measure in liters. For battery? Battery capacity measured in which unit? ampere hour. Charge, how much charge you put in the battery is the capacity, ampere hour. So you see here, I have plotted here in milliampere hour per gram. So I am keep on increasing ampere hour. At the time the voltage of the battery keep on increasing. Like potential energy, here voltage is increasing. Correct, no? Once it is full, I am discharging the battery. Again voltage is decreasing as the capacity decreases. Actually I should have plotted here. From here I would have decreased the capacity, but I only increased the number. You can think like this: 0, 50, 100, 125. Then you can consider this 100, 50, 0 like that. Okay, but I have put in this number. So we can plot in terms of specific capacity versus voltage, or we can plot in terms of hour. Okay, or we can plot in terms of something called state of charge. What is state of charge means? What fraction of your tank is filled. So when I say state of charge 1 means completely tank is full. That means battery is fully charged. So I put 1. So in between it will be 0.5. Then when you go this side will be 0.5 empty. This was 0.5 filled. When I go from here to discharge, it is 0.5 empty. Then completely empty. So I can put it in terms of state of charge. This is called state of charge. How much charge left in the battery is called state of charge. If I completely fill the battery, state of charge is 1. If I completely empty the battery, state of charge is 0. Or I can plot in terms of X. Remember this equation? When I remove lithium from this, it becomes Li 1 minus X. So that X also can be correlated to this capacity, no? So when X is say 1, formula is LiCOO2. LiCOO2 is a discharge material. That means that is the starting point of the completely discharged battery. Now I am charging. As I am charging, X will change. X is 0.75 means 0.25 is gone. But here I used 1 minus X, there I am using X, that is a confusion. So if X is 0.75 means what? 0.25 is left. Okay? And 0.5 means 0.5 lithium is left. So that composition here will be Li 0.5 CO2. After that again I am started discharging. When I am discharging, I will put lithium back into the lattice. Then it will become 0.75. That means I added 0.25. Therefore from 0.5 it went to 0.2. So I can plot it in terms of capacity, in terms of stoichiometry, or in terms of state of charge. This is the common charge discharge curve you will see in the papers, research papers. Okay, right? Some people also use depth of discharge. This is state of charge, like the depth of discharge. Depth of discharge means how much you discharged. So the depth of discharge here will be 0, 100%, right? Why? Because here while starting battery is completely discharged. So depth of discharge is 100%. Here depth of discharge will be 0 because battery is completely charged. Here depth of discharge will be again 100. So you can use, say, when you change the terminology, the numbers will accordingly change. So what all we have seen? We have seen how thermodynamically, whatever you have learned in thermodynamics or kinetics, we transform into electrochemistry equivalent. So you now know galvanic, electrolytic, concentration, how it can be galvanic, electrolytic. What else? Rate of the reaction to current density, and work, PV work, non-PV work, how to convert to electrical work. Then from there how to convert into cell voltage, right? And you have done some examples, correct? And then slowly we came into solid state chemistry. We have done the electrochemical series, how to construct that, how to change the reference, how to rescale it, how to construct a battery out of those electrochemical series. Then solid state materials like graphite, triangular lattice, honeycomb lattice, how a triangular lattice can be FCC lattice. Even though FCC lattice is there, I can go from cubic to rhombus using LiCOO2, and you have seen a charge discharge reaction finally. So we stop here. Like that I have so many materials and structures, so we will stop here. Okay.
SwayamPrabha, Digital India, Educated India.